This topic under the find the first point of intersection of four perpendicular from the line and point to the plane. Alright, so the general idea is like this. Okay, so we have our plane, right? So our plane is r dot n equals to p, so equals to d, right? And then we have to find the four perpendicular r, so point r is somewhere here. Alright, we have to find this point Q from point Q, and then the fourth perpendicular is point R. Right? So we need to find this position vector R. So how do we find this R? Okay, first what we need to do is we need to take this. Okay, we need to find the vector equation of the line QR. Okay, so how do we do this? I'm going to show you later on. So basically, we're going to find the vector equation line QR, and then we solve it together with the vector equation of the plane. Right, that's how we're going to go about doing it. Okay, so next up, okay, find the coordinates of the four perpendicular R from the point Q to the plane with the equation 1, 1, negative 2, 3. Okay, so we have a point Q, which is 2, 0, 1. Alright, so going downwards, it intersects on the plane. This plane is point R, we don't know what is it. Right, to the plane, and our plane over here, alright, has the equation, vector equation in scalar product form, which is R dot product with 1, 1, negative 2 equals to 3. Okay, so first up, what we need to do is we recognize that actually here, 1, 1, negative 2, right, is the normal vector to the plane. Okay, and we now let's try to find the equation of the line RQ or QR. Okay, so we found position vector 2, 0, 1. You recognize that actually, right, because you can also say that here, because the normal vector here, right, this normal vector is also the direction vector of your line RQ. So that means, right, the equation of RQ, okay, given that is a plus lambda m, right, RQ, it can be written as what? It can be written as position vector 2, 0, 1 with a direction vector lambda, okay, 1, 1, negative 2. 1, negative 2 is the normal to the plane. It should be parallel to your RQ, so it should give you the direction vector for RQ, because again this is also perpendicular to the plane. Alright, and after that, right, what we do is we need to find the four perpendicular. We need to actually find the intersection of RQ and the plane. Okay, so we know that on RQ, right, to find the point intersection, we know that on RQ, on the line RQ, right, okay, your x, right, is equals to 2 plus lambda. Your y is equals to lambda. Your z is equals to 1 minus 2 lambda, right, from the vector equation. This is from the vector equation that we have just found, from the vector equation of a line RQ. Okay, and then with that, all you need to do is just sub it into the plane. Okay, on the plane, right, the vector equation of the plane is r dot 1, 1, negative 2 equals to 3. So at the point of intersection, right, it should fulfill both the vector equation of the line as well as the plane. Meaning, right, since we know this r is represents x, y, z, what we do is we sub them simultaneously. So on that point of intersection, at the point of intersection, right, there should be some lambda. There exists lambda, right, such that 2 plus lambda, your x, your y, your z, right, this forms the r, right, dot product of 1, 1, negative 2, right, should give you 3. So your x, y, z, you sub x as from the line, right, 2 plus lambda, right, y equals to lambda, z equals to 1 minus 2 lambda. Okay, from here you dot product, you should have 2 plus lambda minus 2 plus 4 lambda equals to 3. This will give you 6 lambda equals to 3. This will give you lambda equals to 0.5. Okay, so very quickly you can see you sub this lambda equals 0.5 back here. Alright, you can see that x should give you x equals to 2 plus lambda 2.5, y should be equals to 0.5, z should be equals to 0. So that means, right, what's the coordinates of r? What's the coordinates of r? The coordinates of r should be equals to 2.5, 0.5 and 0. So this is the coordinates of r, which is the foot of the perpendicular from point Q to the plane P. And hence, next we need to find the shortest distance from Q to P. So you recall, this is Q, this is P, right, your plane, looking at it from the side. This one is R. So basically, what the question wants you to do is just find QR. That's all. Find the distance QR. Okay, so how to find the distance QR? Very easy. We just take first one. We just maybe find QR first, right? The direction vector of QR. This would be OR minus OQ. Alright, it should give you OR is 2.5, 0.50. OQ would be 201. Right, so this will give you 0.5, 0.51. Okay, so quickly go to the side. Magnitude of QR, the distance here would just be the magnitude of 0.5, 0.51. Okay, so this is just equals to square root 3 over 2, or otherwise if I rationalize both top and bottom, it's square root 6 over 2 units.